I am super stoked for this session to learn more about Yuya. Just as a quick introduction, Yuya Ong is a founding member of NDL, completed a lot of undergraduate research and just cutting edge work while he was studying applied data science at Penn State, and is now a research and engineer with IBM. So I'm super stoked to hear his insights. Just a quick kind of calendar update for everybody before we get going. On the 28th, Wednesday of this week, we will be doing a kind of co-hosting a workshop with Developer Student Club, doing some machine learning and using GCP. So keep an eye out for that, and we hope to see you there as well. But with that, I am going to pass these controls over to Yuya, and yeah, we will get going.
Sounds good, and thank you very much, Jordan, for the great introduction on that. So without further ado, I'm going to be jumping in. Okay, I hope everyone could see that. So thank you all for coming out to this talk on Sunday evening, I think, yeah. So the title of the talk is From Happy Valley to Silicon Valley. So it's really just kind of a story kind of letting you guys know, what happened once, I got my degree at Penn State, a data science degree at Penn State, especially since I was one of the first batches of graduates. So I kind of wanted to give back and kind of like, let you guys know what happened and like what to expect, and kind of giving a little bit of the picture of like what I do at IBM Research, how you could get into a career where, you're dealing with machine learning, data science on a day-to-day basis. And towards the end, kind of giving you sort of an insight as to what the market is like right now and what you should do, or what I think, are valuable skills that I think should be really honed in order to meet sort of the market expectations. So that's kind of like what I'm hoping this talk to be, and actually there's quite a lot. So without further ado, just a little bit about myself. So I graduated from Penn State just last year through the Applied Data Science program at IST. And I was one of the first two batches. So there was, I think, only like two other people that graduated with me. I know also there's Vince Trost, who's another NDLer in the past that also graduated before my batch, but I think that to be sort of the official first batch. So currently I work as a research software engineer at IBM Research. So within IBM, there are many different business units. So there's one for GBS, that's like Global Business Services, Global Technology Services. There's also one for systems. So this is where you see a lot of like the mainframes or some of the big machines that, IBM was quite well known for. And then we have IBM Research, which is this whole research arm of IBM, which does a lot of the cutting edge development. So I currently work there out of San Jose, California, as a research software engineer, specifically in the focus areas of AI, right? Machine learning, deep learning, also reinforcement learning. I also do a lot of research in federated learning. So if you guys take in, DF300, which has to do with data security and privacy, that's one area of work that I focus on, is how do you train models through enforcing, through keeping things in mind of like privacy and, the utility of data. I also started getting into a lot of work with the optimization and operation research. A lot of my work will actually permeate along with cloud technology. So that's actually one of the biggest focus at IBM is this thing called hybrid cloud, which is essentially, how there's like AWS, GCP, Azure, and IBM, cloud. Essentially, how can you combine many of these cloud services so that they kind of come together as one unified infrastructure? And that's what kind of like the strategy is for IBM, sort of like cloud direction. And also much more recently, I've been taking a lot of interest in quantum computing, because partially IBM also does a lot of like cutting edge work with quantums. And I've been fortunate enough to work with a lot of quantum researchers and to kind of get my hands on, working with the real quantum computer, and also looking into the direction of how we can integrate AI into, using the quantum hardware that's available. So some of the latest achievements or some things that I've done in the past is I've published 2 books on data science. These are in Japanese, so unfortunately you can't get them here, but those are a couple of things that I've been writing since the past 2 years. I've also filed around nine disclosures so far, currently working on 7. And then I have also been actively developing new algorithms for some of the services for Watson machine learning. So I'll get into that a little bit. But before that, kind of going into, rewinding back into Happy Valley 2015, this is the first week I was in Penn State. And mainly the way I got started with machine learning in general was through the MOOC. So there's like the massively online, open courseware kind of like whole movement that began somewhere around 2013, 2014 with Coursera, edX. I'd taken a lot of courses during my high school for machine learning and AI. So in particular, that's what kind of got me into this space of being able to, get myself into the sort of this AI and ML space. And so right as I kind of came onto Penn State, one of the first things I wanted to do was join a research lab. So immediately, first week of college, I decided to just spread my resume around to several different professors saying, hey, like, I know a freshman, but I kind of know machine learning and a little bit of deep learning. Can I join your lab? And luckily, I was able to get a position under Dr. Wong, James Wong. Maybe you might have taken his class. His research and work focuses around on computer vision mainly. So he's well known for his work on analyzing, art pieces from like Van Gogh, analyzing these different painting strokes, and then being able to identify which artists in particular drew that picture, be able to identify forgeries. Another line of work he does with this is, I think, with AccuWeather, I believe, building weather prediction models from image satellite. And this particular work, which I helped to kind of pave the way, was kind of doing emotion modeling. So the idea here was, can we learn to better understand human emotions from multimodal inputs like body language, right? So being able to identify key points like you could see here in the background, and also understand what it means to be, to be able to tell whether someone's feeling happy or sad, right? Using not only body language, facial expressions, micro expressions, right? And also the other part is with machine learning, one of the key things to really think about is representation learning. So another sort of tangent that I kind of like looked into during my undergrad was how can we best represent emotions? Because emotions aren't necessarily something that you could use, like one hot encoding, right? Something that you could discretely describe, because sometimes you might have mixed emotions like happy and sad together, or maybe, bittersweet. How do you describe that in a computer, right? So those are the kinds of things that I kind of worked on. And so I think this research now is being currently funded by Amazon. So I'm glad to see that sort of the impact that I kind of contributed towards that work. And so the other part, that made a really, really big difference at State College, right, was Nittany Data Lab. So NDL actually started out as really this indie club. So it wasn't a club that was officially recognized by IST. It was more of like something that was like in the outskirts of NDL. So this was actually done in a very small, so it started out as this like, this like sort of like a, people coming around in circles, just pulling up chairs, let's say, okay, let's talk about big data, right? And that's how I kind of got started, right? And when I first joined, like one of the first things, because I kind of had this background in machine learning and AI, I kind of brought in a lot of like these MOOCs and try to like, give lectures, give these workshops. And, that's how we kind of grew this whole idea of building this sort of workshop to be able to train the next generation of students to, be better equipped with like learning how to work with data, how to build models, how to deploy, how to engage with clients, right? And that's kind of where we also brought in a lot of the consulting. So those were some of the two major directions that I wanted to really bring Nittany Data Labs. And, as the years kind of grew on, like we've grown this community to a point where we've had at one point probably over 1,500 active members, right? And like it was so big to the point where like even like during these hype meetings that we'd have in the beginning of the semester, obviously can't do that today because of COVID, we would literally fill classrooms with this, and like you could see with like a lot of people kind of like gaining interest. And I think this, and also the part, and partially because of the major, right, of the applied data sciences and this whole data science program kind of came together. So our objective really was to see if we could bridge the gap between, you know, faculty, the students, and also the industry, right? We also want to also give, you know, students the opportunity to connect with other industries, right, to be able to have, you know, a successful sort of pathway towards the job. So we wanted to be this sort of liaison or this bridge that would narrow the gap between all these pieces. And then one of the other sort of the main highlights, I guess, in my undergrad was this whole thing about Salon AI. And I think this is one of the questions that was brought up in that Q&A kind of thing. So Salon AI was a little bit interesting because originally this is something that I wasn't interested in, but another former NDLer, Vamshi, kind of looped me into this, saying that like, hey, you know, there's this business case competition, right? And usually with business case competitions, you don't really have to build something per se, or you just need to present like, you know, hey, here's like the business model, here's like, you know, what we plan to do, you know, these kinds of more business aspects. But, you know, we were thinking, you know, if we want to like present something that's like feasible, why not actually build it? And we kind of came across this idea from L'Oreal where they wanted to define what the future of the salon industry looked like. And, you know, for us, the salon industry was something that, you know, was a complete, you know, foreign concept to us. And we had a lot of fun kind of like interviewing, you know, stylists, consumers, also getting to know a lot about the industry, and then seeing how we could bring data into that. And that's sort of like what the sort of the main challenge here was, is how can we deliver, right, integrate, you know, pieces of information that we could pull from, you know, interactions between a client and be able to build something that we can make use of insights, right? So be able to use machine learning models to, you know, recommend products, recommend hairstyles. And this is where this whole idea of the smart mirror came across. So literally what we did was we just bought stuff off of Amazon. And I think the wood planks you see there, those were from the student bookstore that I just randomly bought. And then within 24 hours, we just put together a whole prototype. We, you know, got together a deck like this to kind of showcase what the features of the mirrors were. And we actually won the nationals representing US now into the as a finalist as France. Oh, and by the way, one of the reasons why I actually decided to do this was because my friend told me we actually could get a free trip to Paris. So that kind of like my motivator behind all this. But in the end, we actually, from that old scrappy prototype, we actually built a real working smart mirror using a flat screen TV. We had this whole custom glass thing that was done locally, and it came out really nice. And it even had a particular feature at the top. You could see here, I'm not sure if you can see that clearly, but there's a webcam. And basically what that webcam does is it could read your facial expression and be able to analyze in real time, say your facial emotions, right? Or also you could do sort of this smart mirror like augmented reality, where basically it's like the camera will capture what it sees on the face, and what will happen is on the projection of the mirror, it will bleed through on the display like different hairstyles. So it's kind of like a Snapchat filter, but it uses a mirror. So there was a lot of like these computer vision tricks that I had to use to get that sort of working. But in the end, it was a pretty fun experience all in all. So after I graduated from Penn State, got my degree, my diploma somewhere up there, I then had the opportunity to work now with IBM Research Almaden. And so IBM Research, I was able to get this opportunity actually through my professor in my research, who had a connection with this lab because he was a former visiting professor there. And so I've done 2 internships there. And then after that, I was able to get a full-time offer. So through here, so just a little bit of background of what IBM Research is, and particularly it's just a collection of these labs. So my lab is right here in Almaden. This is San Jose right here, but there's also a couple of labs in New York, Yorktown, so that's sort of the headquarters. There's also one in Cambridge. There's also in South America. It's just all over the place, right? And there's over 3,000 researchers, 19 locations, and we're across 6 continents. And out of these, many brilliant and talented people, and constantly learning, new things every day from these people that like really know their things and really, work with, the cutting edge. And it's very interesting because every day you're working with people from across, different specialties. So sometimes there might be one person that might be working in hardware, that might be working in a cloud development, that might be working in ML ops, neurosymbolic AI. And so oftentimes you get to collaborate with a lot of people, and this is really what drew me into IBM Research. This is fact that you get to work with a lot of different areas, right? And that's what makes cutting edge research innovative in the sense that you're mixing, doing these sort of interdisciplinary work. And that's, I think, sort of the main things that I embody is this idea of balancing out, theory and practice and all these different areas that might not seem connected at first, but if you could find the connection and draw them together, that's kind of what draws together something that you can call innovation, I think, right? And so currently at IBM Research, we're really focused on these 4 different pillars. So first is this sort of strategy behind hybrid cloud, as I mentioned, kind of coming together with these different competing services as one particular system that could, work together. And that's actually one of the research work I do is how do you train machine learning models across these different hybrid cloud systems, right? And that's also another part of this AI, right? IBM Research is also big in AI, and with AI, we do things from like neurosymbolic AI, neural networks, deep learning, reinforcement learning, adversarial machine learning, anything. You can name anything, and there's probably a researcher that's working on something related to that topic. We also do quantum. So in this case, we both work on the hardware side of it. So this is kind of building quantum computers, so building the actual quantum circuits, right? And also the actual system that allows people to interface with it. So we actually have today, you actually can use a real quantum computer, and it's free. So you can actually sign up today and actually start using this on one of the actual quantum hardware to run quantum experiments. And there's a lot of applications to this, not only in the AI space, but also in finance, chemistry, right? And also in sciences, new material discoveries. And that's also another component, sciences, right? We also not only do, chemicals, materials, we also do batteries, some of these fundamental, research technologies that IBM sees, right, that can benefit their whole research portfolio. And these are just some of the things that we work in. So a couple of the things that I worked on, it's actually quite a lot, but I'm just going to briefly go over some of them. So right around when I started my work at IBM, one of the first things that I worked on was time series forecasting. So this was kind of coming up with new deep learning architectures for multivariate time series. So that's like, say, given the price of like the stock market, say from the past week or the past month, can we, forecast within the next day, next month, next week, right? What the price is going to be like. And that's the kind of models that I've been building. And so one of the things that they wanted me to work on was how can we develop these sorts of models specifically for handling, multivariate uneven sample time series. Because, typically when you work with time series, right, you might expect, your time series data to, come in, at data intervals at like, say, every hour, every second, every month, right, at a very uniform rate. But in this particular problem, we're working on time series where, these time ticks aren't necessarily, coming at the same rate. So maybe at one time you might have one data that could come in 1 second later, then 10 seconds later, the next data point comes, and so on and so forth, right? And so that's one kind of research I did with time series. Another one was how can we exploit missing data as signals? So typically when we work with missing data, right, we often think about like, getting rid of them or imputing them, right? And like kind of like thinking that, these are bad data. But what if I told you that sometimes missing data can be data or signal in it of itself, right? And so that's sort of like the kind of the work that I did, was seeing how we could exploit these signals to maybe give like hints as to how maybe a particular signal might behave, right? And that's a couple of the things that I've worked on and wrote papers on along. Another kind of work I did was more on this line called federated learning. So if you've taken DS 300, right? So one of the big things about that class is, talking about data privacy security, right? We often hear about, data privacy breaches, GDPR, and all this kind of things going on today with like, how we don't want to give our raw data. So, because machine learning algorithms need data, the question is, how can we train machine learning models when the government, these regulators are coming after us, right? And we want to use this data, but we can't do it without being able to expose like these raw personal information, right? Or be able to utilize these personal identifiable information. So the idea of federated learning is to be able to train machine learnings together, but do so in a way where you don't exactly reveal the exact attribute of your data. So for example, say you're working with a particular bank, right, and you don't want to expose or maybe reveal a particular person's say social security, or maybe their gender, their age, their demographics, where they are in terms of income levels, right? We want to keep those things private, right? And so there's several techniques that you could use to kind of to introduce sort of privacy, for example, adding noise, or maybe using encryption. And so a lot of this work was done mostly for neural networks, but not so much for XGBoost. So one of the things that they tasked me to do was see if I could come up with a XGBoost way. So XGBoost, for those of you that are not familiar, is sort of a decision tree based algorithm that uses sort of gradients to train, essentially using a sort of the loss function to decide how do you do the splits between the trees. So those are just some of the kind of things that I've developed for IBM, and now it's currently being used in as a product at Watson ML. So you can see that immediately a lot of the work that you do gets translated into applications that other businesses will get to use, and that's sort of the immediate impact that you get to see here at IBM Research, is seeing your research work getting turned into practice, right? And another one, which I think is more practical, I think, would be sort of this idea of the sales pipeline prediction. So, IBM, right, is mainly a company sort of like in the tech consultant sort of business, where we offer sort of our technical expertise to other businesses. So we kind of work under sort of a B2B, business to business sort of model, where we say you maybe go to Google, or maybe go to like, for example, Apple, or maybe Mars, or all these other companies, and we provide them with these solutions that we build, for example, for HR, for maybe finance, for maybe, onboarding, new users. So in order for us to be able to sell these, right, we have sellers that go to these companies and be able to reach out to them and say, hey, we have these sorts of things. Or maybe a company might be asking IBM, can you develop this sort of system for us, right? And so the idea here is, can we actually predict how likely we are going to, win these engagements between these businesses? And it takes a lot of different, back and forth between IBM and the company, right? Weeks after weeks of like understanding what the requirements are, understanding what these different sort of expectations are, what the price is, what's going to go into the product. And, we want to really look at the behavior between the sellers and the company and determine, right, whether we're actually going to get this deal, right? Whether they're going to sign the contract and we get to, start working with them. So one of the things I do here is to build machine learning models to be able to forecast that. And another work that I think is a little bit more interesting and a more on the theoretical side, right, is how can we look into combining sort of this idea of taking, domain experts and machine learning models, right? How can the two work together, right? Because one thing about machine learning is that your models are really limited by the data that like you train it on, right? So like say you get a data set of like, particular things you scraped off the internet, right? You are limited only to that data that you get on the internet. But maybe there are people already in the industry, right? Say, for example, sellers that might have, some intuition or better idea of what the market is like, but isn't really contained in the data itself. So this work that I kind of focused on was how can we get the two of these models to work together nicely? And so one of the things I did was kind of create an algorithm that can be able to fuse these two sort of aspects together. So mainly it comes down to saying, for example, if you take the example, for example, the whole sellers with the B2B clients, right? The seller might say, as the price of our contracts go up, the probability that that another business might actually buy into this will be fairly low, because like who wants to pay like 100 million to like 500 million dollars, right, for this sort of like machine learning thing that could be that maybe another competitor could do it for much cheaper, right? So using this sort of intuition that we capture from human knowledge, can we represent this or integrate it into machine learning models? And that's sort of like one of the directions that I took with this research, and actually published a paper very recently in this space. So to kind of give it a little sense on, what's it like doing work in sort of industrial research, and how does this differ from, a lot of the other industry, right? Or what is it like just doing machine learning in the industry? So a lot of possible careers that you could take on with machine learning. Actually, there's a lot of titles that you see out there, right? When you kind of search on LinkedIn for like data science or like machine learning, right? So you might have machine learning product manager, machine learning DevOps, machine learning dev engineer, ML researcher, scientists, data scientists, engineers, and you're like, what the heck is this? Like, are these just like terms that people throw around? Like, what do they mean by when someone says like data scientist versus, a machine learning researcher or scientist, right? So, and it gets a little bit confusing, I think. And so to kind of break it down, right, it really looks at, different types of functions specifically. So an ML product manager, right, similar to some of the product managers you see in software development, is working more with, machine learning teams, businesses, the users, and the data owners, and to really think about what the business or, what the, the machine learning, team needs to focus on, and kind of guides and builds the roadmap of the product, right? So they work on design frames, design docs, right? And they use tools like Jira and all these other sort of toolkits to actually, to kind of craft what the product will look like and what kinds of ML will go into a particular product, right? And then there's this other one called machine learning DevOps engineer. So if you've never heard of what DevOps is, right? So DevOps is basically kind of how do you build robust software, right? Because when you build software, right, you're going to tend to run into bugs, and you don't want to ship software that's buggy, right? So typically you would have to go through testing, you would have to go through QA checks, make sure the code runs well, right? Make sure, someone didn't, forget, a semicolon or maybe some logic error there, right? And so similarly, machine learning, right, it goes through also the same process, right? When I give it this particular input, right, do we expect it to, predict, this correctly, or does it not blow up in terms of when it sees like a weird error input or something like that, right? Or how can we efficiently deploy our models, right? Are the models, doing well in terms of production, right? Are we, hitting our metrics for how accurate our predictions are, right? And it's kind of looking at the life cycle and the whole thing about the whole sort of deployment of these things. And I think this is one of the things that I don't think a lot of schools cover today when it comes to data science. And I think this is one of the biggest demands right now that I see, is this whole thing about machine learning DevOps and engineering. I'll kind of get into a little bit more detail as to what this entails, right? Another one is data engineer. So data engineer focuses more on the data pipeline, right? So even before you could have like all your fancy machine learning models and all of your data-driven stuff, you need to have, your databases. You need to have a way to be able to collect data, to be able to read, write, right? Anything you've done in data science 210 to DS210, DS220 with like your database, those are the kinds of things that data engineers work with. So it's kind of building this whole infrastructure so that later, business analysts or machine learning, engineers can actually use that data, consume it, and deploy models on top of it. So machine learning engineers now are people that, train and deploy machine learning models. So these are the people that take, existing frameworks, right? Like Keras, PyTorch, scikit-learn, all the tools we love, right? And train models, deploy them, right? To be able to do this sort of data science work, the kind of work that they teach you in the class, right? So that's what kind of ML engineers really focus on, right? Whereas ML researchers, right, it's sort of similar to ML engineer, but we get to have a little bit more of a wiggle room in terms of things to experiment with. So maybe this is kind of dealing with, new models that have been tried before, or maybe kind of building new neural network architectures, new maybe decision tree algorithms that hasn't been considered before, and kind of like pushing the envelope to see, can we maybe train machine learning models that require less data? Maybe, can we deal with the things like with privacy security, right? And kind of pushing the sort of the cutting edge into that. So typically for me, I work, and this is kind of where I sit at, is this area between, this awkward area actually between researcher, engineer, and data engineer. And so for me, I actually wear a lot of hats. Actually, as a matter of fact, I wear probably all these hats, and I'll kind of get into the reason why. But typically, yeah, there are cases where you might have to wear more than one hat. So it's not necessarily this sort of like one bucket that you fill into, right? And the last term here, data scientist, is sort of like this generic term that's actually used by the industry that actually, if you look at the job description, can almost seem to fit any of these other things. So it's kind of like a big blanket term to say, we expect you to do everything from building the latest machine learning to models to, deploying it, to doing the infrastructure, to, talk to the clients, and to do the PM, right? And so that's sort of like what some companies that aren't too familiar with data science might use as a term, and you kind of have to be careful. So especially when you're interviewing with like companies, you want to clarify with them what sorts of responsibilities you'll be looking at, and kind of see whether, this is something that you want to do, right? And so really, if you're really confused about where you fit in as to these sort of different roles, one way I like to look at it is to think about it in terms of two axes, right? So on the x-axis, you have this idea of saying, how theoretical do I want to get with my work, right? Do I want to be not so theoretical, but, still having a high level understanding versus, I want to like dive into the research papers. I want to dive into, the math, the linear algebra, the calculus, and everything that deals with the algorithm, right? So that's more the theory aspect of it. But also on the other spectrum, you have to look at it in terms of, how much coding do you want to do, right? Because with coding, right, there's also things like that you have to deal with, right? Things like, how to use GitHub, how do you use some of these cloud services, how do you use, Kubernetes, Docker, right? These sorts of containers, right, that you see a lot for like cloud deployments, right? You need to have a lot of these understanding of these tools that they use in industry to be able to scale your machine learning to a lot of people. So you could see here that right around, say, for people that tends to have, maybe a low theory in machine learning and low software engineering, that gets more into the product managerial side, right? Right in the middle, right, where, you don't have to do too much software engineering, but maybe having a somewhat of a decent understanding of machine learning theory, right? This is where your data scientist would sit, right? All the way at the end of the spectrum, right, you have your machine learning researchers. So people that write papers, do patent work and all of that, right? Like the cutting edge kind of work. And then you have your machine learning engineer where, they have a little bit more understanding than the typical data scientist, but they also have some level of expertise with regards to developing machine learning model, right? Your data engineer needs a little bit more work in terms of understanding, how to do these deployments. So not so much, software work as an ML ops, but maybe, a little bit less theoretical than, say your regular data scientist. So you could see that you could actually float in between these different areas. So kind of like see where you fit in this map, and you kind of gauge and identify where your strengths and weaknesses are, right? And that's kind of what I recommend when you're kind of looking for a job, is to position yourself in this particular niche. So when you're looking for a machine learning job today, right? And I think in particular with COVID, it's become a lot more difficult because a lot of people are applying for jobs, but there are a lot of ways you could actually kind of go out there to look for opportunities. Other than like, some of the standard job posting career sites like LinkedIn, going through, campus recruiting, and all these other places that we typically go to. But sometimes, attending conferences, right? And conferences, right, typically are, places where we get to exchange information about the state of the art, what's going on in the industry. And also it's a great opportunity to network with other people. And this is where, a lot of companies actually go to conferences to look for talent because of the work that a lot of the people share. And so this is also another great place to kind of showcase and maybe to talk to, and reach out to some of the companies there to see, if you could maybe get an opportunity there, right? Of course, you can apply directly at the company website. So, there's probably lots of listings there that you kind of browse through, apply, right? Sometimes, cold call, emailing, right, is also another big thing. And a lot of people actually, email me, going to cold call or email, reaching out to getting opportunities into the door. And this is something I highly encourage you to do, because sometimes one of the meaningful connections that you could get through, might be just from an email away, right? And this will be a great experience, not only from a career point of view, but also from your education point of view, right? Learning, maybe finding a mentor, right? Also, it's a great place. We also have a great NDL alumni network because, we have, some of our graduates that are out there. I know we have in IBM a Slack channel with a bunch of Penn State alums. And, it's kind of great that to see, other people that, graduated from the same college, to be able to reach out and, they might be able to offer you a position there, right? Just because of the Nittany Lion sort of like title that we are associated with, right? There's also social media networks, right? Twitter, Facebook groups, Reddit, Discord channels that you could also go to, because there's a lot of great space there for industry connections too. Because there might be people, researchers out there that are also in these places that are actively engaging with the community. And also, a couple of other content aggregation places like Hacker News, Lobster. They typically have a monthly bulletin board to see what kinds of jobs are out there. So with this, how do you really stand out, right? Because one of the things that we see, I think what makes this industry really competitive is that, we're taking all these same classes, right? We learn the same kind of algorithms, we learn, go through the same things, right? And typically everyone goes through very similar kind of sort of this training. But in order for you to distinguish yourself between one or the other, right, you really need to work on several different things. So one of them being, working on your software engineering skills and having a really solid CS foundation. So your data structures and algorithms, leak code your way through the interview, right? All that kind of good stuff right there, right? The other thing is exhibiting interest in machine learning, right? So attend these workshops, meetings, meetups, online courses, do anything and everything you can to just absorb, a lot of the content out there. And there's so much free content out there that it's kind of you don't have enough time, but you kind of want to engage with a lot of these materials. So definitely whenever you have the time, just keep on digesting and, read a lot of papers and have some big knowledge about it, right? And the third thing also is, don't just be a consumer of information, but also be a disseminator of information, right? So demonstrate that you also have broad knowledge. And this is something I see a lot of people do is, write blog posts, become a YouTuber and an influencer, we have this huge kind of like platform for social media to be able to reach out to a wide variety of audience. So why not leverage that to our advantage to show how much we're capable of, right? Maybe become the next machine learning TikToker, right? I mean, I know, like, for example, Vince Trost, I know is a data science Instagrammer and YouTuber kind of thing that's going on. Definitely check out his channel. Other things you could also do, right, is work on real world machine learning projects, right? So you could create, do side projects from, things that you might be, that you might have an interest in, right? Pull a data set from Kaggle, do Kaggle competitions and do sort of these other things, right? And, maybe reproduce a paper, right? And also the other thing is, rather than, reproducing or, building these models, see if you could think creatively with a machine learning. Can you build maybe the next machine learning algorithm out there, right? And those are just some of the ways, these different kinds of things you could do to better have yourself stand out from the rest of the crowd. And I think that's what a lot of these industry people will kind of like pay attention to. So how do you prepare for machine learning interviews? So I'm just going to go through this really quickly, but basically it's make sure you know your data structures and algorithms, understand your, machine learning basics, right? So understand what some of the different algorithms are, loss functions, some of the feature engineering techniques, review your machine learning theory, right? What is, F1, what is precision recall, right? How do you do cross validation, right? What is bias and variance? What is recursive dimensionality, right? These kinds of basic things they will ask you, right? They might ask you, hey, derive, how do you do backprop on the whiteboard, right? So that's kind of like the similar equivalent to like the whiteboard coding interview kind of thing, right? But there might also be questions where they might ask you, more from a system design standpoint, like say, okay, how, if I gave you, a data set of all these past, user views from like YouTube, how can you build a recommender system, right? And you kind of have to walk through the process of how you would build the model, how you would do the feature engineering, how would you deploy it, how would the end user make use of it, and how would you do the evaluation, right? And to kind of be able to walk through the process of how would you build a product, right? Because at the end of the day, you want your skills need to contribute towards, generating revenue, generating clicks, generating, whatever metrics that they need to meet. So what skills, right, should I focus on in particular to be more industry ready? And so this is kind of where that whole idea of ML ops and DevOps, I think, come into play in particular. So a lot of the things I realized when I was at Penn State is that we tend to focus a lot on sort of like the learning to build machine learning models, deploying them, and it's more tends to be academic, but we never really focused on what it means to actually practically, build an API to be able to handle, say, predictions, to be able to deploy, to be able to do retraining, right? And in order for you to do that, you really need to have your own sort of infrastructure to facilitate that, right? So can you say, build a machine learning model that can digest data from a database system, then into, system that takes that data from the database system, train the machine learning model, save that model somewhere, maybe in a cloud object storage, and then maybe how do you deploy that into production? And when maybe someone say, or say someone's like looking for the nearest McDonald's or restaurants or some recommendation, right? Can your model generate predictions for that, right? So being able to build your own sort of stack, similar to like software engineering, your own research and development stack to be able to do the data engineering, the data feature pre-processing, all this compute kind of stuff. So a lot of these things I think you should start looking into. And one of the things that I think becomes really important is being able to train yourself to be able to use this early on in your projects, because once your projects get really complicated, you'll start acquiring things, what's known as technical debt. And so what I mean by technical debt is like, saying that like, say, your boss asks you to train a machine learning model, and, you have to train, you build your model in a Jupyter notebook and then you deploy, right? But maybe say a few weeks later, that machine learning model kind of does pretty poorly, right? And then so later you have to go back and retrain your model by hand and deploy, right? So you kind of like have to do this sort of back and forth, right? So rather than doing that, right, can you make this process more automated? Can we automate this process? And that's sort of what it means to like, reduce your technical debt, right? Make it easier to sort of do this end-to-end process. The other thing, right, once you get into industry that I think a lot of people make a mistake on is like, typically when we do, machine learning, right, we have this like notion of like, hey, let's throw a deep learning network at this, or let's throw maybe the most complicated thing on to it because, it works really well. But you have to realize that sometimes these complicated looking models and all this, right, might be an overkill. And sometimes they don't scale well. Sometimes they take up too much GPU resources to the point that it becomes impractical to even maintain. So the idea here, right? So there's this thing called Occam's razor, which means just start simple, right? And basically the idea here is just like get whatever you could get out the door, even if it's like a linear regression or logistic regression. And this could save you a lot of time and effort, in particular when you're working with like business, with the business side, because with the business side, they want to always see some kind of progress being made, right? And I think the important lesson to take away from once you start working in the industry is you want to always show them something, right? And so if you start with something too difficult and it takes time to kind of build that difficult thing, your client's going to say like, what's going on? Like, I expect to see, a machine learning model, that does this, right? Once you have something out there, right, you start to have an expectation for what the business will expect, right? And you can start kind of building on top of those expectations and then gradually making those improvements. So the main sort of takeaway here is be practical, start simple, keep it simple, silly, right? And also the last thing, right? Binge and learn. So this is kind of my favorite thing, always be learning, right? So, we're in quarantine, we have nothing to do, right? You might be watching, the rerun of Office or whatever. But what if I told you could spend that time rather than rewatching like the whole season of the Office, to actually take that time to maybe go through an entire semester's worth of like college content, right? For like machine learning or like, reinforcement learning, and be able to learn all the time, right? And to always keep up to date. And so this is something you should be doing, right? Because in data science, it's always evolving, right? And we're always in this sort of this constantly changing, like the state of the art, it's always going to change, right? And so you need to keep yourself updated with the latest literature. So the idea here is that just, constantly be digesting information, whether it's through watching lectures or reading articles. If you're watching lectures, my recommendation, go 2 times the speed. Just optimize your time just for the breadth of the content and don't worry about the depth. Because when it comes to depth, I only typically focus on depth when it's only on a need-only basis. And this could save you a lot of time, right? And will only allow you to will be a lot more practical when it comes to like, say, say you're with the project I was working on with XGBoost. Before I started with XGBoost, I didn't know too much behind the exact proof and formulation behind it. But once I needed to work with XGBoost, that's when I needed to, get the papers out, read through the papers, go through the proof line by line, go through the code, right? And only focus on the things you need to focus on only when you need to, right? Other things you could do, right, is, optimize your social media algorithms to only show you things relevant to machine learning. Actually, it's really easy to toy around with recommender systems, right? So like if you constantly click on a lot of the machine learning algorithm, the machine learning like articles and all this kind of stuff, your recommender system will give you a lot of like great articles actually for machine learning, and it'll help you kind of like keep up to date. So, really at the end of the day, right, my advice in general is just, follow the gradient, right? Learn from your mistakes, right? The gradient, get it? enjoy the ride downhill towards your next optima, right? And always be back propagating, always be learning, right? So yeah, with that, I'm going to be answering some of the AMAs, or ask me anything, any questions you guys have so far.
Hey, if nobody else has one, I had one I kind of wanted to throw out real quick, something I was wondering.
Yeah.
So, you were kind of, as you were going through the different roles of, how you can kind of engage and create a career out of data science. You mentioned kind of the ML engineer being, the opportunity to work with, sklearn and Keras and kind of the packages that we're all familiar with. But at the same time, with a lot of the market moving to like a more cloud-based infrastructure, do you think that the future lends itself more to kind of being comfortable in that environment? And, what does the future of like local-based models look like?
What was the last word? Local based?
Yeah. Like, so as opposed to like, running a model on my local machine, I'm going to push something out to a cloud infrastructure.
Good question. Because so a lot of the things right now that's happening in industry, and in particular, this is one space that I'm not quite concerned about, but this is something to kind of keep in your radar, is that there are work being done on these things, on these new class of like ML systems called auto ML. Basically, it's kind of like automating the stuff that data scientists do, right? So typically when we work with data science models, right, we typically go through the process of reading the data set, doing the data pre-processing, doing the feature engineering, doing the, fit, like doing the model fit, then doing the model predict, then doing the evaluation and comparing, which models are good, doing the model selection and say, okay, here's my model, right? It's a pretty standard process. It's a process that can be automated, right? So what people start to realize there is that, if you kind of like look at the trend behind how machine learning has been, and machine learning, deep learning has been going, right? So in the beginning, we had regular machine learning where you have these like fixed kernels, right? These fixed models, right? For being able to learn a particular function, right? And then we start to move into this thing about doing feature engineering and this whole science of like science and art behind how do we build the best features, right? And then deep learning came along, right? Where deep learning's objective starts to go into more, how can we automate the process of doing feature engineering, right? And then now you start having neural networks come up with, how do we build the next, the best deep learning architectures, right? And then so you kind of start to see the pattern there where, the models are, start to build the models themselves. And, we kind of want to get to that point where we're starting to getting to that point where a lot of the work that data scientists are now doing are starting to become more automated. But the one thing that I think that I think still requires sort of that human element is the domain knowledge, right? Because kind of the work that I kind of mentioned before about how one would work with specific domain, right? As to maybe how the data should look like, or maybe how the things should look like, right? I think a lot of the focus in terms of where data scientists can spend a lot of time is being able to hone in on taking other industries and working with other industries to incorporate machine learning together. So when it comes to utilizing the services that are out there today, we could just throw all of our data into these cloud infrastructures. But I think what our role as data scientists should be more focused on is, how do we work with the client? How do we work with the business side to kind of like integrate sort of the features, sort of the data that would feed into these algorithms, right? Because at the end of the day, garbage in, garbage out with the data.
Gotcha. Okay. That's very interesting. Thank you. Appreciate that.
Yep.
We also had one question come in from chat from Vince. He has thoughts on the trend of pre-trained models and transfer learning.
So the whole thing about pre-trained models and transfer learning, there's been a lot of exciting things going on, especially with the recent thing with like OpenAI and GPT-3, right? So for those that are not familiar with OpenAI, so OpenAI is another cutting edge machine learning lab that's out of San Francisco. Um, and basically they work on a lot of problems dealing with the language models, reinforcement learning. And one of the biggest work that they recently came up with is this whole thing about transformer models, basically language models that could do sort of like human level or supposedly human level machine learning tasks with sort of like these billion size sort of neural network models. And the idea here is that these models, because they're pre-trained on this huge set of corpus, can actually stem a huge economy, I think, in terms of like sort of the different use cases that that can sort of trickle down to more niche players. In particular, with the example of like Hugging Face and how those sort of communities has really taken the whole idea of these big pre-trained models and then be able to fine tune it specifically to domain needs. And I think this is sort of what the benefit is to of making use of these big pre-trained models. So I see sort of a big trend there, right? Sort of these big companies deploying these big models, and then a lot of startups, a lot of these big, smaller companies taking that sort of pre-trained models, fine-tuning it to their specific domain, and then kind of releasing it, right? And also with transfer learning, it's also another very similar space there too. There's a lot of work that's being done in that space. And I think another space to kind of look into is this area that I also work in called a cross-domain sort of adaptation or cross-domain knowledge. Basically, it's like, say you have like two different domains, like one domain that's maybe specific to biology, maybe another domain that's specific to engineering. And then in the industry, typically, you might have, different knowledge on, how to do things that are on different domains, but maybe there might be something that we could learn from one domain to the other. So is there maybe sort of a AI equivalent of that where it could actually make use of this sort of lateral thinking like patterns to be able to share one sort of aspect of insights and transfer that to a different domain, right? Even though they're completely different domains. And so that's sort of another research area that I actually spend a lot of time in, and have a couple of papers that are in that space that are about to be published soon.
Awesome. Thank you. Appreciate that. I guess there's a couple of questions that were dropped in on the earlier kind of with the pre-session submissions. There's some that really stand out as lighthearted, and then also those that have like some real kind of, I think, practical knowledge behind them as well. So I guess let's start with the lighthearted one. What are your favorite machine learning moves?
Okay.
Oh, okay.
Yeah,
oh,
actually have all that stuff. So
okay, right on. I know you had these,
yeah, so this
is
so this is the one with L'Oreal. I think I've already answered that. Oh, this one. How often do you sleep in college? Right. Okay, so this vary depending on the semester. So like some semesters, most semesters I've taken like probably more than 20 credits on average. In addition to like working with like research lab and then MDL. So there were a couple of times where I would have like, so I bought like this Penn State neck pillow. So like the neck pillows you like wear in the airplane. So like I'd be walking around campus and like in classrooms with these, and practically I would be sleeping sometimes in the library. So that in the library, one of the computer labs, I think it was in Petit, with the sliding glass doors, there used to be like this big couch area near, and there's like this whiteboard and like two TV screens. I don't know. I think they meditate at that couch, but But basically, yeah, that used to be like my go-to sleeping place, that I would just basically sleep there for an hour or two, just like, and then work the rest of the night typically. But yeah, but in all seriousness, get sleep, because, you know, with data science, I think one of the big things, like something that I realize, is that if you don't have enough sleep, like sometimes you could like mess up really big. And I've had a lot of like big cases where I've messed up, like because like I might have missed like, you know, a couple of like I've just made like silly mistakes and bugs because of lack of sleep. So definitely get sleep whenever you can. So the other one, right, where do you see the brightest opportunities, new interesting portfolio projects that will help stand out from the rest of the pack? So I've already answered partially this kind of thing, but I think one way to really think about interesting projects is, you know, it can really come from things that are just like out of the ordinary every day, right? So I was actually with my coworker the other day, or about like last year, and someone was telling me, you know, like, why are there a lot of like mattress stores? Like, do you notice that like the time that like we actually, you know, actually go to a mattress store and buy a mattress, like it's not something that we like typically go out and buy all the time, but like, why are there a lot of mattress stores? Right? Like, have you ever just thought of that? Like, but so I thought about that for a while, and then I decided to just like scrape the entire like Google Maps, figure out like, you know, like just go dig into the data, and I actually spent about a week or two on this. And it turns out that like there's an article that you could probably Google that actually goes into the economics behind this. But, you know, there's just a lot of things you can do, right? It really starts with just thinking of questions that you know, that you might be curious about, right? Or it might be things that might be so, you know, that you might be dealing with every day. Like, for example, because like, you know, we're working from home, you know, and we have so many meetings, so many things that are going on. You know, how do you prioritize the things do we do, right? How do I make use of my time efficiently? Can you maybe use data science to make that more efficient, right? Maybe track every day how much time you spend on what task, build an optimization algorithm. Bam, you have a project, right? So, you know, a lot of these things would be hiding in plain sight. So let's see. What would your top 3 most helpful rules for going through life in this data and AI space? So I think I've already kind of addressed that with sort of like the industry things. But I think one other thing that I kind of want to drop in here is that be mindful of your cognitive biases. And this is a really, really big one that I think a lot of us don't realize metacognitively, but I think is something that you should be aware of, because sometimes when you tend to work with like machine learning models, right, or like you work with a particular data set or feature, right, you have this hypothesis to say, you know, I feel that, you know, a particular thing might work well, a particular thing might, you know, do, you know, might perform well because, you know, I know this for sure, right? But sometimes those things can be influenced by our bias. And there's a lot of, you know, if you Google like cognitive biases, you probably find out a lot of things, right? But I think it's a good exercise to be aware of, you know, when you might be falling into these traps, right? Because sometimes, you know, because, you know, there might be things that, you know, with like things like correlations in particular, right? Sometimes just because they're correlated, they're not necessarily, you know, there isn't sort of this like causation, right? Direct causation between, you know, these sorts of things we need to be really careful of as data scientists. And I think it's always, you know, a good thing to have, you know, to have a good sense of like skepticism, right? To always question your work, right? Because sometimes if your models are like coming up with that, you know, really, really high 99% accuracy, most likely, you know, you might have slipped up somewhere with the, you know, a particular feature, you know, like a data leak or, you know, some kind of feature that's, you know, giving away into that. So you might want to just be careful of that, right? Okay, this is the one. What are your favorite machine learning memes? And so this one was a hard one. It literally took me a long time to figure this one out because I have a lot of I literally have a huge file of memes, and I also make my own memes as well. But I think the best one is actually not a meme, but it's a bunch of these Twitter accounts called these board Twitter accounts. So for those that are familiar with some of the sort of the pioneers that are out there, like Jan LeCun, Jordan, I don't know how to pronounce his name, but it's like Jordan, that's, or Benjo, right? Joshua Benjo, Joshua Benjo. They have like these parody accounts of these like machine learning researchers, and like sometimes they like to like joke around. And you can just read through their tweets and you can see, yeah, like if you know like Epic Rap Battle, if you've ever watched that YouTube channel, they kind of did like a play on that, and like they went through all this kind of like, you know, rap battles on Twitter. So go check them out. So yes, that's it. Any other questions?
So I did have one other question I wanted to ask you. You know, with your experience and then also reaching such a unique position within data science as you have, you know, one of the things that I think has intimidated me, particularly as I started studying data science, was the fact that a lot of times, you know, even just looking at job postings or people who are kind of working on cutting edge stuff, you find that like there's a lot of people who are coming from an academia background or, you know, really ultimately have a PhD in like mathematics or something like that, right? So where, you know, what kind of experience, or I'm sorry, advice do you have, you know, kind of surrounding getting into, you know, data science and AI, you know, without maybe having that high academic background?
So one of the things I typically did when it comes to breaking down, right? I think what really intimidates a lot of people, right, when they start getting into the more theoretical side is the mathematics, the theory, the concepts, and I think a lot of the language that they use, right? This is kind of like almost speaking a different language, right? The way they present these materials, right? And so I think really what it boils down to is to kind of break it down into smaller chunks and smaller pieces, right? So for example, when it comes to reading research papers, right? What I typically like to do is to typically sort of translate or to basically take parts of the paper and simplify it to words that you can understand to the point where you could actually recognize or understand it, to basically reword papers in a way that you could interpret. That's sort of one strategy that you could use to maybe help you understand a research paper. Or say if you have like a huge like loss function, right, on like that you encounter with a paper, right, with like these different Greek letters and symbols and whatnot, right? What I would say is just annotate the hell out of that paper, right? Question what every single variable is, what every notation is, right? Make sure you know what every piece of that equation means and be able to explain it, right? Say like this equation does this and it does this and that and that. Make sure you could get it to that point, right? And even with the reverse, right? Even with not only reading these papers, but also writing papers, and also when you're working on your class projects, right? Especially, I think you'll learn this when you do like 340 when it comes to like learning to write papers. My suggestion is to make it easier for others, right? Is whenever you're going to like slab them with a huge loss function, give it like annotate like what parts of the papers, what parts of the equation mean what. So like for example, what does this whole summation piece mean? What does this whole expected value mean? What does this whole probability function mean, right? Translate it in a way so that you can understand it, right? Because if you don't understand those smaller pieces, right, then eventually you'll have to kind of like build them up like kind of Lego blocks, and then to get it to the point where you can see, aha, this is exactly what this algorithm is doing, and kind of take it step by step, right? And I think that's sort of like the best thing, is to essentially chunk it down to the part where you understand, right?
Gotcha. Okay. Yeah. Yeah. That makes a lot of sense. I appreciate that. Thank you.
Any other questions?
If nobody else,
I have a question.
Oh, hi Vince.
Hi, Yuya. How you doing, buddy?
How are you doing? It's been a long time.
Can you show us Takuya?
Where is he?
Grace the Nittany Data Lab people with your beautiful Siamese cat.
All
Please
right.
and thank you.
All right. Give me a second. Let me go pull him out. Hello. Here he is.
Yay! Yes.
Hello.
See, folks, this is what you get when you graduate from Penn State with a data science major. You get a good job, then you get a great, cute cat.
Yep.
That's the
it's all the
dream.
motivation you need right there.
Exactly. It's all you need.
Yep. Alrighty then.
Thank you, Yuya.
Thank you.
It's awesome. Well, hey, you got one of the, I guess I kind of just, if you don't mind, I'll kind of interject a question that we had talked about briefly on one of our earlier calls that I think is super valuable. It really intrigued me. So just, you're in that unique position of having to strike the balance between research, kind of corporate business, B2B being part of that element. And then you kind of introduced the idea of consulting earlier on as well. So like, you kind of shared your insights into how you strike that balance between, how can you be cutting edge and take the risks that you do or that you want to within the research kind of arena, but then also providing like real value to the company that you're working for or the clients that you're working for.
So the question was how you can kind of leverage between the two or kind of feed between the two. Is that what the question was?
Yeah. Mm-hmm.
Okay. Yeah, that's a really good question. And actually, there was a really good talk that I highly encourage you guys to take a look at. I can probably send you guys the link. Or if you type in Ronald Fagan from IBM Research, he's like one of our actually one of our pretty senior researcher there, whose research ancestry, right? Actually, if you follow like his great professor or PI was the mathematician of Albert Einstein, and actually he gave a really great talk on what it means to actually transfer or work with theory and in practice. So when it comes to really looking at where theory fits into practice, right? It's really looking at, say, for example, you're working on a particular business challenge, right? And so you come up with a particular problem that you run across, right? You might try different algorithms. You might try, your standard regression models, your regression, your XGBoost and all of that. But sometimes you might be faced with the opportunity to say, is there a way maybe we could bring in this sort of new data in? And if there's a very creative way to be able to try something new, and that's where you might introduce a lot of researchy aspect into it, right? And that could actually translate into a particular interesting research problem. So actually, one example of this was with the sales work, the business or sales work that I'm doing right now is, as we're like starting to track like, different sales of like, say, sort of in this B2B space, right? Say you have like different snapshots of your data, right? And for every opportunity, you have these different components, right? So every big deal might be composed of many smaller deals, right? And then within those smaller deals, we have like different transactions and like these kinds of things, right? And then you want to maybe say make use of this whole data structure as a time series. But with time series data, you're expected to have a fixed number of time series. But in this case, we're working with a data set that's maybe, you know, say you have like different features or different sizes of these time series. And that we discovered actually is a much harder theoretical problem than, you know, we originally thought it to be. And that's how it actually became sort of this research area that we kind of dug into, right? There's that one example of how, you know, you can translate theory into practice, right? So taking your everyday problems and see if you could flip it in a way that's really challenging, right? Maybe add constraints, maybe change the way you look at that problem, right? And that's where you kind of come up with interesting questions to do research on. On the other end, you might have an algorithm, right? Say that human AI and intuition, and say, you know, where can we apply this into practice? So maybe this whole, you know, human intuition AI work actually could fit into this whole sales pipeline kind of work, and say, you know, can we incorporate, you know, experts from the sellers and combine this with our machine learning models to improve the predictions of the machine learning models, right? And so in that way, I think it's kind of like being able to switch sides and to kind of like spend a moment to think about how you could apply one side to the other.
Very interesting. That's like such an optimization problem in itself, just to kind of work through that and find that balance. It's really unique.
It's really tricky. And also, yeah, and one of the other biggest things, right, is that you don't guarantee that whatever you're about to do is, you know, going to work out, right? Because you're playing a huge risk there, right? So, and this is kind of the reason why I said, you know, start simple, the Occam's razor thing, right? It's because say like you, because if you, you know, start out with something really, really complicated and that really complicated thing fails, then everything's going to fail, right? But like if you start out with something simple and then you gradually ramp up that complexity, and then that last complex thing you do fails, you still have something to fall back on top of and say, hey, you know, at least we have this working and we can still deliver it, right? So.
Yeah. That makes a lot of sense. Any other questions from anybody else in the group?
Yeah, and I think Vince said here a couple of other great resources to, you know, to kind of like pay attention to, right, is Archive, which is basically where it's kind of like the mecca, or like I guess like the holy place for where all research papers kind of come out. This is a really great place to always keep up to date with the latest papers. I have a sort of a Twitter feed, right, or this Twitter account that I follow that would, you know, post all of the research papers that come from Archive. And basically I would, you know, click through the ones that are interesting, you know, just read through them, you know, very quickly and see what's, you know, what kind of new innovation there is, right? And if I'm interested, you know, I would typically, you know, throw them into the pile of, hey, maybe I want to try implementing this, or maybe I want to take a look at this, or, you know.
Hey, can I add one?
Yeah.
I think a great learning resource for me personally has been searching through your GitHub stars.
Yes, my GitHub.
So, folks, when I say this guy's always on GitHub, like I mean it. He's on GitHub like most people are on Facebook. It's insane.
I'm addicted to GitHub. Like I'm addicted to Instagram or like Twitter. That's like it's really bad. Like you go down a rabbit hole.
Yeah, but it's so useful most of the time because I hop on GitHub maybe, you know, 3 or 4 times a week, and I go on and my feed has like Yuya, your Utah Rochan started like 5 different repositories, and I sort of passively look through them, and they end up being like super cool repos that I otherwise would not have known about. And they're usually implementations of papers, and these papers have pretty innovative ideas. And that's like, I think maybe like once or twice, at least maybe a handful of times, I've seen him star repos. I look into them myself. I realize how cool they are, and then I drop them in the NDL group me. That's kind of how it goes.
Yeah. Honestly, there's a lot of interesting hacks from GitHub that I have that actually could be pretty interesting ones. So a couple of things I use. Actually, I use GitHub. So you how people use GitHub to typically push and pull code and work on projects collaboratively. But there's actually other interesting uses of GitHub that I haven't really discovered that I started making use of. So one of them is being that, right? It's following other GitHub users that might share interests in particular thing, watch what they star, right? And this is kind of one of the things that a request that I wish GitHub had is this whole social component where you can see what other people starred and from there, it could be a good recommender engine, right? Hey, that's a little data science project, collaborative filtering on stars, right?
Great idea. See these side projects come up all the time.
They just come up all the time, right? From discussions like this every day. It just pops out of nowhere, right? So that's one, yeah. And then the other one is what's that? The other one is using GitHub repos as a way to kind of do a journal keeping or keeping track of research paper summaries. So there's this really interesting GitHub repo called Archive Times. It's actually from a Japanese user that actually did this, but basically what they do is they utilize the GitHub issue. So in GitHub, there's a way to be able to communicate whether there's problems in your code, and people typically will pull tickets, and they pull these tickets called issues, basically where they describe what the problem is and do all that, right? So rather than using it for that use case, they actually use it in a way where they populate a particular GitHub repo with summaries of research papers, basically TLDRs of what the paper is about, what's the results, what are the impacts of it, is there any code or is there any data sets with it? And it kind of gives a really, really nice way to look at summarized research papers. And it's also a great way to look at what other people did, and also a great way for you to do the same as well. So you can kind of contribute to the wealth of information to help other researchers be able to quickly sort of gain knowledge from research papers rather than having to sit down and read through 12 pages. So
yeah, I think that plays very well into your whole point about turn social media into your own learning resource, right? Train the algorithms that are trying to keep your attention.
Yeah, don't let the algorithm take over you. You have control over the algorithm, right? I mean, you guys are data scientists. You know how this stuff works. Take that to your advantage and control the machine.
Exactly. Moral of there's whole social dilemma movie thing.
Oh yeah, I haven't watched that yet.
You should. Well, I mean, it's not going to teach you anything, but it's going to be example A of exactly that.
Yeah.
Right. Yeah.
That's awesome. I've not heard of the paper summarization, so I definitely want to check that out. And hopefully have a more informative feed every day.
Yeah.
And even so, just following people that are big players in the AI space on Twitter, it'll give you such a better grasp of what's going on in this industry.
Yeah. And interesting enough, a lot, and one thing you'll realize is that a lot of open discussions about research problems and, observations that people make about particular models, they tend to have these huge Twitter threads that you should follow, right? And sometimes a lot of research work actually spins up from Twitter feeds, actually. And that's how, and I've seen times where some people that were collaborating on Twitter ends up writing a paper together just from this tweet storm or these tweet threads that just pop out of nowhere. It's the dynamics of research has also been changing quite a bit these days. And, it's really good to kind of get involved into that space and also reaching out to these researchers too. And I think because, it makes it easier, right, to talk to these people and you can just like, just at them and just like talk to them, ask questions. It makes it way too easy, right?
You're right, completely right. I had like a major VC reply to me on Twitter when I sent him a message about a question I had on some podcast he was on.
Nice.
And it was like I had no intention of actually getting a reply, but within a day, replied to me, gave me an answer. Like, it's unreal how accessible these people are, all because of Twitter.
Yeah, that's true.
That is interesting. It's admittedly not something I've leveraged as somebody who doesn't use Twitter, but I think that's about the greatest sales pitch you could give me as far as like a real practical like value add to like education, career, just life.
Oh yeah, everybody in here should be on Twitter. If you're wondering who to follow, find me or Yuya on Twitter. Look at who we follow, see if there's anybody you like. That should be just enough to get you started.
Yeah. So, any other questions? Any other comments? Maybe things that maybe helped you guys so far? I'd be interested in hearing about that. Also want to see what helped you guys, or what you think are really great advice. I'd be very interested to learn more.
I guess I'll pop in with this is far from ungrounded advice, but just something that I've kind of noticed is, like data science it's a large field in that you can apply it to pretty much any industry that you like, essentially. And so I think like one thing that's valuable and maybe not touched on quite enough, although I think they actually restructured the applied data science major to maybe account for this, is like trying to figure out, like what are you passionate about applying this to, like, so if you have this toolbox of skills, that's awesome, but then you could effectively go take that anywhere. So you need to kind of figure out how you can leverage this to work for you, both like in a way that's going to build you a career, but also be like kind of self-gratifying as well.
Yeah. Definitely. I think it could certainly give you leverage, right? Because you have these skill sets that, other people, say in like those industries, typically won't have. So it gives you a really strong competitive advantage once you start joining that industry or that particular field or industry.
Yeah, I'd say I'm like 2.5 years out and I'm still trying to figure it out. It's beautiful to have this kind of a skill set, but like the plethora of different places you can apply it is sort of like something you need to figure out, right?
Yep.
Yeah.
But you don't ever have to worry about like being stuck in one domain and not liking it, because worst case, you can just pick up and learn a little bit about a different domain and switch over.
Yeah. Escape from that local optima, head to the next optima, right?
Love it. Love it.
Yeah.
Always be back propagated.
Ever in search of your global minima.
Yep.
Well, we successfully gone a half hour over time.
Yes, we have.
Yeah, this has been both extremely informative and also really entertaining. Does anybody have kind of any last minute questions or thoughts, comments with both Yuya and Vince here, representing kind of the OG NDL squad?